Remind me. Hey, Keegan. So I have a question of you guys. If somebody, in case of an emergency, let's say I'm trying to have a designated person to tell people to leave the class. So if I were to, um, the internet were to, it's done that to me last year, pop me out and you guys are all in the class. So it's always better to have somebody tell everybody. So why don't you guys go ahead and leave? So because the I have to turn the class off and then you have to come back in. So and sometimes it takes me forever. I mean, it may not even I may not even be able to turn the computer the class off until I find an emergency. Is anybody interested in that? Anybody interested in Jay, are you interested in that? Yep. So if there's an emergency that you'd be the person the emergency. Okay. All right. So Jay, I'm going to have you do that. So you're going to be my emergency person. Emergency. So and you're okay about that. So just in case lose that. Oh, you would do that. I'll make you the secondary person, okay? Scylla. Uh, all right, secondary, second in charge. So you, if just in case Jay's not here, I would appreciate that very much. Heaven, happy birthday to you! Woo! Birthday today! Woo! Birthday today! Let's do this. Happy birthday! I wish we used to be able to write on cards and so forth, and but now I can't even see that. So happy birthday, Heaven! Heaven, happy birthday! Everybody say happy birthday to Heaven. Got anything planned, Heaven? I know I embarrassed you in front of everybody. So, do you have anything planned at all? Large. Happy birthday. Come on, move this over. Okay. Come on. Oh no, I'm going crazy here. I want to just hit the thing so I can get it. I don't want to just make it bigger. There we go. I'm asleep all day. Hey, well, that's good. Good, good, good. Okay. All right. Um, so let me and again, did you get it? Did you want anything? Did you besides the sleep in? Do you have any? Did anybody going to get you any gift? Did you ask for anything special? Ask for anything special? Usually clothes. Clothes. We can never use enough clothes or shoes. Oh, I just want money. Okay. Yeah, then you can decide what you want to buy. Yeah, yeah, yeah. Very good. Very good. Thanks for being here, you guys. We look like we got 17 people. Let me just do some housekeeping stuff. Okay. Power School 1. So let's take a look at this screen here. Okay. So if you will take a look at what's going on today, all right. So, what does matter? We have a density lab tomorrow. We're going to split up the class into two different classes, and one group's going to watch a video and then the other group is going to do on density. So we're going to do like I'll tell you what we're going to how we're going to split it up. And you should. I got the notes. What does matter notes for today? Looks like I forgot to save this, but you should be able to get to the work assignment 1, 2, and the quiz this week. Those are actually counting. These are not bonus. So if you go to module, it looks like I didn't link those yet. If you go to module week 2, they're there, so you can do them this way. It looks like my home page is not working really well. Also on the home page, if you'll take a look here, if I have a new thing here. It's called the homepage link. All right, so it goes back to homepage 1, and it'll show you the home pages. So if you want to get particular, like if you want the videos that I put in here on the assignments or the notes, this is how you get it. So you click on this. Can I do this? All right. Let me do a student view. Let's see if I can get student view here. See if it's working. I did it last night, but it's possible I forgot to do it. Yep. Okay. The link is not working, so that means I forgot to save it. I'm sure I've got a page for it. So I'm going to write myself a note. Fix homepage. Fix for first hour. PS1. Fix homepage. Homepage and links. Because I've got so many classes. I got 4 classes and 4 pages, and I forget those kinds of things. Okay. So, all right. So I apologize for that, but I worked Saturday and Sunday, and I've gotten you guys' homework done. So if you have any questions, make sure if I sent you the homework, if you did the metrics, not the metrics scientific method bonus questions, I sent people a video on how to fix it. So if you got less than 10 points on the bonus, I have a fix for that. Or if you didn't start it, and some people sent me stuff that was blank. So it happens. I didn't mean to send that, Mr. Gale. I was doing it and I accidentally did it. Hey, thanks for coming in, Madison. Let me check the chat real quickly. All right, thanks, Jay. He said, give me money. Okay, all right. All right, so am I missing any questions here? Okay, any questions from you guys? Any questions? So this is where it's starting to count. The assignments do count this week, besides the bonus. So the worksheet 2, week 2, assignment 1, 15 points. These are unlimited. This is one try. Okay. So I made a mistake and put one of them. The instruction said unlimited, but it's one try. Right. So if you want another try, you have to talk to me. I will give you an extra try if you know where the notes are, because you can use the notes on these things. So use the notes for these assignments. Okay. All right. So let's take a look at what we're doing today. So where are we? Okay. What is matter? Okay. So we're going to start this lesson here. So this counts as participation points. And this counts as your 50 points that count for in the 9 weeks. You get 50 extra bonus points. I will give you this link. Right. And I'm going to clear the chat from the happy birthdays. And I'm going to put this in here. Okay. So we're going to be talking about matter today. And just to give you an idea of what we're getting started, because this is chemistry, we start from the basics. All right. So let's go open teacher's dashboard. Okay, I'm going to put that over here. All right, so I can see that. And again, Jay or Selah, if somebody's writing in the chat and I don't see it, let me know. You might have to what do you want to call it? You might have to say, "Excuse me, Mr. Gale," and if you're comfortable with that on the mic. Somebody's got a question and it's urgent. Okay, sometimes I'm looking at many screens here. So what is matter? Okay, so and you may have seen this before, but in physical science, chemistry, science classifies substances and puts them in categories and keeps things organized. All right, and we are going to use PhET Lab this week for practice. I can participate in class and classify substances. All right, so it's a lot of vocabulary, a lot of vocabulary. And again, some of this stuff may seem obvious to you because, but you got to remember when science was early. Yeah, that's I don't know why that's doing that, Madison. Good question. It's those are bonus assignments. It doesn't happen to any class, but I have a tech time today at 3:30, and I'm going to ask them what the heck's going on. So I apologize for that. Nobody should have any grade in there except for bonus points, and the bonus points get added in the 9 weeks. So for some reason, it shouldn't be that. But as soon as you take W2 assignment 1, it should populate to grade, and that should help it. So but that I appreciate. That's a good question. That's a real good question. All right. So science, in the last 100 years has made so many changes, and people back then didn't even, way back 2,000 years ago, thought we had 4 elements: earth, wind, fire, and water. Okay, that was it. 4 things. And we know much more than that. I appreciate your question, Madison. Really do. So we know more than that. But again, we have extraordinary equipment. We have stuff that people do at home that they've never been able to do before. People have their own home labs. It's amazing, amazing stuff here. So what do you have in common with a toaster, a steaming bowl of soup, and a bright neon sign? Well, you're all made of matter. Okay. And you guys matter to me. Now that's a difference. So when I say you matter to me, that means I feel for you. Do you feel me? I used to have students, as you'd say, do you feel me? It's like they want a connection with me, right? And they want a connection with each other. Um, Matter is anything that has mass and takes up space. So that's what we're going to do today. We're going to talk about mass and volume and so weight. So those are the 3 things we're going to be working on today. We have an assignment, and that is something we're going to do together. It's a form, a Google form, and that counts as a bonus points for you. I'm going to mark it down in the on my physical science work 1 chart. It's my chart. So okay. So, and if we can keep the chat, if you guys have, I will read the chat. If we can keep the chat to the questions that are about matter and volume and space. Okay. All right. So I got to go there. So all matter takes up space. There's some types of matter in it. In the room, there's a chair, there's bugs. I don't have any bugs, but I have a lot of dust, books, air. So that's interesting to think about because people don't think that we know that matter. Does air have any weight? Put it in the private chat. Tell me if air has any weight. Maybe I can make that question. I can do that. Does air have mass? Okay, upload. Let's see. Let's start a poll. Does air have weight? And if it has weight, it has mass. And mass, M-A-S-S. Okay. So let's just do this as true or false. Yes, true or false. Air has mass and weight, or false, air does not have mass or weight. Okay. See how many people are doing this. Does have mass. Does, instead of a question, I should, air has mass and weight. Right. And some people say, well, you know what? I put air in a balloon and it flies up. Well, okay. Usually it flies up if you have helium, but helium, even though it is flying up, has weight and mass. It just is lighter than the air around us. So air has some mass. So publish the poll here. Okay, so it does have mass and weight. So even though you can't, it's hard to tell, but it does. It does have air, mass and weight. So 9 people said, 15 people responded. I really appreciate that. That's a good way of checking. So next time I ask that question, you're going to say, sure, air doesn't have much weight, but it does have mass. And you think about it, air, if you had if the wind did not have any mass or weight, when it became a tornado, it wouldn't be pushing you around, would it? Yeah, so it does have some. Thanks so much, um, Revi. Yeah, it does have some. It does, and it does destructive forces, hurricanes, especially. In order, if it didn't have, I mean, it's like light doesn't have any mass, and you get hit by a bright light, you might close your eyes, but you're not. It's not pushing you around. You can get a laser, and then you could burn something here. Because you have volume, you cannot share the same space at the same time. Every tiny piece of dust takes up space. Another piece of dust cannot share the same space. So here's a kind of a demonstration here. Um, so again, air has volume and takes up space. We already asked that question. I forgot that I had this in here, so I'm going to move on. So we're going to do this one. So if we're going to crumple up, here we're going to crumple up a piece of paper and fit tightly into the bottom of a clear plastic cup so it won't fall out. Turn the cup upside down and lower it straight down into the bucket of water. Lift the cups. What do you notice? So let me ask this question. What do you predict will happen to the paper? Get wet or dry? Get wet or dry? Will it get wet or dry? Oops, I don't want to do that. Close window. I wanted to look at responses here. All right, so let me do this. I wanted to open this up is what I want to do. So did you have to drag okay, I got 5 out of 11. Okay, not responding. Okay, why am I not responding here? All right, can I see these or no? Presenting, oh, why is this going to be a problem here? 6, okay. All right, so it's going to be, most people are saying it's going to be dry. Some people say it's going to be wet. So let's take a look at this experiment over here. I'm going to take my head off because I'm just turning my head over and over again. Okay, so I'm going to do this one. All right, see if we can click the presenting button here. I don't like this guy talking, so I'm going to show you his experiment here. So there he goes. He's got a paper that is in a cup and he's going to push it into water. So he's going to do this. Come on, do it. Do it. Do it. Don't keep talking. All right. Push it in there. All right. So let's go. Okay. So notice there you can see the water underneath here, and it is totally dry. So if air did not take up space, then the water would go in there. Okay. And so air does take up space. So it's one of the things that it decides whether it's matter or not is if it takes space. Now, if I put a hole in the cup, the air would pop out of there. So the, that would be the case. So air does have matter. We know it takes up space. All right, so Lake Erie, the smallest of the Great Lakes, has approximately 483 trillion liters of water. Picture 2 liter bottles, 241 trillion 2 liters. That'd be awesome. So we're going to work on this today. We're going to look at the graduated cylinder. So we use a graduated cylinder, and graduated means that it has lines on it. Graduated means it's graduated into lines. Push it in. There is crazy. Okay. Hey, Janaya. Yeah, did. You guys do those in middle school? We had graduated cylinders. We're going to work not with graduated cylinders. We're going to kind of just read them. So good to see you, Janaya. Okay, so you remember that it's precisely measures the volume, and they use the word milliliters. So in milliliters, so this is something, an ml is a milliliter. It's also equal to a centimeter cubed. Length times width times. So the three-dimensional space, when you have the length times width times height, you get a volume we call centimeters cubed, and milliliter is a volume, and it's equal to a centimeter cubed. Now the meniscus is that curve. So if I draw a graduated cylinder and here's a line, the water has this thing called capillary action, and it wants to rise up the sides of this. So we measure to the bottom of the meniscus. Meniscus is, and I think I've torn my meniscus. So it's a curve. That's the curve. So there's a meniscus in your bones in your knee. There's a right and wrong way to measure using graduated cylinder. You don't use the top, use the bottom of the curve. How many people have heard that before? Remember that from school, from classes way back in the day? You can put yes or no if you remember. So we're going to practice this. Okay. So we're going to practice this in an assignment. Volume, regularly shaped objects, we use length times width times height. Now that works for cubes, right? Cubes and rectangular shaped objects. Okay. Cubes, length times width times height. So if this has a volume of 3, okay, I'm sorry, a length of 3 and a height of 3 and a width of 3, 3 times 3 times 3 times 3 is 9 times 3, so this is 27 centimeters cubed, or if it's a liquid, we'd say 27 milliliters, ml. That looks like an L. All right, so centimeters cubed, having 3 dimensions, so 1 centimeter cubed is 1 milliliter. All right, so that, now again, if the surface looks like this, it looks like a prism and is a triangular shape, then you have a different formula. It's still length times width times height, but you have to use the area of a triangle, which is something we're not going to talk about. But if it's 1/2 base times height times this, so it's really half of a rectangle, just kind of half of it. So, and if it's a cylinder, like a coffee can or something like that, it has circumference we have to figure out. So, but we're just going to talk about length times width times height today. So do the basics. All right, so let's practice volume here. Okay, so I'll work this with you. What is the volume of a box of length of 5 centimeters, 1 centimeters, and a height of 2? So remember, we're going to use length times width times height. So 5. And if you're not doing the Pear Deck, if you could put the answers in the private chat so you get some credit for this. 5 times, okay, 1 is 5. And then times 2 equals 10. Right? So 10. And because this is centimeters, it's going to be centimeters cubed. So if you put down 10 centimeters cubed, because my questions might be when we take these, we do this, I might have an answer that's 10, but you always have to remember to put the units by it or it's not going to work for you. Okay, a book has a length of 25 centimeters, 18 centimeters, and 4 centimeters. So I'm going to go 25 times 4, which is 100, times 18. So I'm just going to have to, all I have to do is add my 2 zeros to it, to the 18, 1800 centimeters cubed. Okay, 1800 centimeters cubed. So I got 4 out of 11, 5 out of 11. Okay. 5 out of 11. So it's participation points. 6 out of 11 is right. No, got 5 out of 11. Hey, Byron. Thanks, Byron. I've got you down on as giving me participation points. So anybody else want to put that in the chat? Participation points for Monday. I appreciate it. So, right, guys, it's important. I know bonuses only come every 9 weeks, but really it does change your grade. And again, it helps you stay focused. If Jay says to you guys, hey, Mr. Gale got kicked out of class, everybody has to leave, I'll bet you there'll be 10 people that will be sticking around going and not even knowing that it's time to leave. Okay. Where did the cylinder graduate from? Okay. Oh, I get you. Very good. Thanks, Jay. I was thinking that was a serious question. Okay. All right. So responses. Okay. So let me turn this off. Let me see who is responding here. Keep forgetting on, okay. Thanks, Abriana, Cheyenne, Bella, thank you. Jay, thank you. And Revi. Come on, Alyssa, Madison, you guys. It's a Monday. Let's get to work on this stuff. Okay. All right. 10 and okay. Volume is of an irregular substance. Okay. It's like a paper clip. You can't measure length times width times height. So we use the displacement method. The amount of water displaced in the volume is the volume of the object. Typically, solid objects are expressed in centimeters cubed and expressed are ml. So they are exactly the same thing. Okay, so we're going to put some, if we were doing this as a partner kind of thing, I would do this in class, but we're going to do this together here. Okay, so notice, right, that this is at 17, right? 17. Okay, by putting this battery in here, it went to 22. Okay, 17 minus 22, the volume of this battery you're going to put down here is 5 centimeters cubed. Okay. Oops, not squared. Squared is a surface area. Volume is a volume. So that's how we have to do this. We have to measure by putting something in here. Okay, and this one we have a nail. All right. Um, and this one started at 15. Okay, and it just went up 1. So this is 1 centimeter cubed. Okay, we started at 15 each time. And here we went from 15 to 19. So this is 4 centimeters cubed. And this one is 5 centimeters cubed because it went from 15 to 20. Okay, so what we did, we used the fifth where we started at 15. Oh, I'm sorry. Wait a minute. It started at 17. Let's start with these are, yeah, it was started at 17 on this particular one. All right, so I'm going to say they went from at 15 here. All right, so I messed up, but follow along with me. I'm sorry about that. Okay. All right. You can put those numbers in there. Thanks, Cheyenne, for getting in there. Bella, thank you. Revy's got those. We still have only 4 people. Wow. When I get calling home, I'm telling you, I am going to give some kudos for the 4 people that have been working with me all along. Thank you, thank you, thank you. They're going to be the first person I call that. So if you're putting something in the private chat, you can do that as well. Okay. That's okay, Revy. The writing on the computer does take some time. It's not a problem. Not a problem. Okay. All right, so what is matter? What is volume? Volume is what takes up space. Matter is something that we're talking about next. All right, so another matter is the amount of stuff in it. So if you think about we're talking about atoms, and we'll be talking about atoms in chemistry. So how many atoms something has? So a piece of styrofoam has a lot of air in it. But the atoms, there's very few atoms in it compared to something the same size. So mass is the amount of mass, and mass is different because mass remains the same, right? Remains the same. Mass is something that stays the same, right? But weight is the gravitational force exerted on an object. Now, gravity pulls on everything. You have gravity. It's interesting. Anything that has mass has gravity, and mass is the amount of stuff that makes you up, and it's the atoms. Now, we're all mixtures of stuff, but there are pure substances like elements that are all the same kind of stuff, same kind of atoms. We have different kinds of atoms. We have water atoms, water molecules, and calcium. We have compounds in our bones. And because we live on the earth, we have a particular weight. Right? So gravitational force keeps the objects on the earth from floating in space. The more mass an object has, the greater gravitational force. Okay, so the earth and the moon have gravity, but the earth has a much more gravity than the moon. The moon is, you are 1/6 of your weight. So if you weigh 100 pounds on the earth, you're going to divide that by 6, get about 20 pounds on the earth. So on the moon. So, but your mass hasn't changed. You haven't lost any body parts. The gravitational force is different. And you have gravitational forces that are different on the earth if you get into a high speed elevator going down, for a moment you feel lighter. And if it's a high speed one that's going up, you feel heavier because things are pushing you and using the gravitational force against you here. So mass is the amount of matter in an object. It's always constant. It's does wherever you are in the universe, measured using a balance. Now a balance uses um, something to check the mass. So known masses are used. So in a triple beam balance, it's not a spring scale that uses gravity. It uses a balance. It uses weights or masses to compare the other one. That's why we call it a triple beam balance. Mass is expressed in kilograms, grams, and milligrams. Weight is the gravitational force of an object. It varies depending on where you are on Earth, measured using a spring scale. So if you're stepping on a scale, you're pushing down on a spring, which measures the gravitational force, and it's expressed in science as a Newton after Isaac Newton. So a sponge and a brick of equal size are not the same mass or weight. A sponge has less mass and weight. All right. So a brick, you can tell about certain things. You know, bowling ball and a soccer ball might be the same size, but you can tell the difference just by feeling it. It has more heft to it, has more, um, it feels more solid, feels more weight, also has more mass. So things that have more weight also have more mass. All right, so here's how we figure out a Newton is equal to 100 grams, and grams is our unit for mass. Okay, so when we write down, I have 45,000 grams, and 1 Newton is 100 grams, I'm going to divide by 100 and get 450 Newtons. Now, a Newton, a kilogram is mass, and it's about 2.5 pounds. So 1 kilogram is about 2.5 pounds. We're going to be using grams here. So we're going to take 1,362 1,362,000 grams and then divide by 100. This will give us 13,620 newtons in weight. All right. So a pair of boots is 850 grams. You divide that by 2 and then divide that by 100. Let's see if I thought I had the calculations on there. Maybe it's on my next slide. Here we go. Divide that by 2, then divide that by 100. It'll give us 4 grams approximately. All right, so let's review what is mass. It's what makes the material has atoms in it, and the more atoms that are closely packed together gives it its mass. And its mass is related to gravity. So something that has a lot of mass has gravity, so are attracted to each other. That's how the planets formed. Started with dust, and as it started to clump together because of gravity, the more mass it got, the more gravity it got, and then it started to pull the stuff together. And then the gravity causes weight. So the 3 differences between mass and weight, if we take a look at the slides here, if I ask that question, mass is the amount of matter, and that is always constant. Weight depends on the force of gravity. So you can go back here and take a look at those. 3 differences. What do we measure mass in? We talk about kilograms and grams. What do we measure weight in? We're going to talk about pounds and newtons. But we're going to talk about newtons in science. All right. Draw or type 2 things that you've learned on this lesson today. Okay, if you want credit for that, I got 12 people in here now. So draw or type 2 things that you learned. Okay, Two of them start with M, right? So mass is the amount of the atoms inside. So if I have two objects here, all right, and I'm not very good at my boxes here, but let's say these are the atoms inside, and you got like 9 of them. Let's say 9 of them. And let's say I have an object that is the same size. Let's try to get this. It's not the same size, but if they are really close, they're really packed together in that same space. So a chunk of lead would have a lot more atoms packed tightly close together. This would have the same mass. This would be more. This would be less mass for the same amount of space. Okay. It also, on Earth, this would feel heavier, right? So we looked on weight. Weight is the force of gravity pulling down on us, gravity. Okay. Without gravity, we would be weightless. But we would still have some mass. Still have mass. Okay. All right. Okay, so this is our assignment here today. I'm going to send you a link to this. All right, so this is our assignment. We can work on this together. You can work on it yourself. We've got 15 minutes. You should be able to get this done by the end of the hour. It is not going to be open past this point. So, okay, this is our assignment. Make sure you put your first and last name on this. You know, if you could do me a favor, your first name, could you put the name that you like to be called in there so it reminds me? Tell me if you've gotten in there so we can go over these together. So if you didn't get into the Pear Deck, but you do this, you'll get half credit for today's assignment. So it's called half credit. If you're doing them both, you get full credit, right? And I'll keep track of that on my clipboard, full or half. Right, so if you can get in there, tell me you've got it. All right, I want one more person. Let me know. Okay, we got 3. Okay, so difference in volume in the graduated cylinder when an object is added is called the difference in volume. Okay, anybody know what this one is? So basically what they're asking me here is if I put something in the water and it goes up in water, what do you call it? Because a rock and water can't occupy the same space, so some of the water goes up. All right, I give some extra bonus points for a person that can give me the answer. What do you think the answer is? Thanks, Revy. You're right. It's the displacement method. We displace. Basically, we're taking up space. Okay. Displacement. We displace the water around here and the water goes up. So this is called the displacement method. All right, I have to turn my camera off, or my thing off. It won't let me go. To find out what the volume of an object using displacement method, we use the formula. So what are we going to use in this particular case? I got Revy's got an extra point here. So anybody else besides Revy? All right, so if it starts at 15 and goes up to 20, so the water goes, by putting that rock in there, it went from 15 to 20. We know it's 5. centimeters cubed. All right. Okay. Aubriana says C. Yes. Initial versus. Thanks, Aubriana. I'm going to put that down. All right. So I've got Revi's got an extra. Thanks, Revi. And Aubriana has an extra. Now, don't answer the next one, Brianna or Revi. So let me give somebody else a chance. All right. So it is C. Volume, final volume minus the initial volume gives you that answer. All right. So 150 milliliters of water added to a graduated cylinder. You drop a rock in it, goes up to 150, 160, 170, 180. What's the final answer on this one? So put the answer A, B, C, or D, or put the answer, the number in there. What would that answer be? Anybody else gets a... All right. B is correct. All right. B is correct. Thanks, Bella. All right. So I have somebody with a confused part here. Water displacement, confused, never mind. Okay. So we're basically pushing the water up. If anybody else has a question on there. So the water displaces, goes this much, goes up 30. Right? Goes up 30 milliliters, and that's what we, and that's equal to centimeters cubed. So that is the volume. And again, we can't do length times width times height on this, right? Can't do length times width times height on this. All right, Amy finds of the volume of a graduated cylinder. The volume is 37. If the volume of the pencil was added was 35 to start with, what's the displacement? So how far did it go up? Need somebody else besides Isabella, Revi, and who else? Albriana. Anybody else? It's going up. Moved up. How much did it go up? A, B, C, or D? Okay, went up from 35. All right, B. And thank you for that, Melanie, because it wasn't just 2, right? You had to have milliliters on there. So make sure that it's not just 2. Thanks so much, Melanie. I really appreciate that. Got you down here for some credit for participation. Steve finds the volume of a graduated cylinder. Did I just do this one? Oh, okay, this is different. Graduated cylinder, the volume is 43 millimeter. If the volume was originally 38, what will that be? Anybody besides the ones that have already answered? Somebody new? Oh, Isabella, sorry, I did not see your private chat. Yes, okay, displacement method is correct for that, but I was a little while ago, so I did not see that chat. So what is that going to be? So we started at 38 and we went up 43. Remember to keep the milliliters on it. Got to have the milliliters on it in order for the answer to be correct. D, thanks. 5 is correct. All right. Let me get that. Why don't I have you down here? Okay. Okay. Got you down here now. I don't know my clipboard. So this is 5 milliliters because we take 43 minus 38, we get 5. What instrument is being used to measure volume? Anybody else? Oh, thanks, Cheyenne. Yeah, it's a graduated cylinder, right? Graduated cylinder. Where are we on here? HI. Got it? What is the instrument needed to measure mass? What is the instrument needed to measure mass? Caleb, you got that one? I didn't get you on the I got Cheyenne first. Anybody, if you can tell me what that one it would be, Caleb? Even if you don't have it right, I'm giving you credit for participation. Yeah, you're right. It's a triple beam balance because a spring scale, see, a regular scale doesn't do mass. So it's got to be the triple beam balance. You got it right, Caleb. Thanks so much. Right. So the triple beam balance does that. What formula for measuring the volume of a regular solid? So irregular, it would be that piece, that rock. Hey, Tim. I'm not already. Sis, I did. You've got this already done, Tim, you're saying? All right. So, Tim, can you answer this question? Which is the formula for measuring the volume of a regular solid? So, we got to use the length and the width, height. Which one would that be, Tim? Okay. Well, length times width times height would be letter C. Thanks for answering, though. Okay, so it's this one, length times width times height. So a regular solid has this something we can measure using a ruler. So it's length times width times height. Okay, we got a couple more minutes left. What is the curve of the liquid surface called? So what we're basically looking at is when we measure a graduated cylinder, we have to look at the bottom of this curve. All right. Anybody there want to answer this one? All right. I got Caleb. I got looking for a new person. Looks like we got Caleb and Cheyenne, and it's correct. All right. I'm looking for that. So that is the meniscus. Weird name. Okay. I'm sure it means something if I do some research on it. Right. The amount of matter an object is called. The amount of matter. Okay. Thanks, Cheyenne. That's the mass. Right. It's different from the weight because the amount of mass is what we count up, but then the weight is the what we have for gravity. All right. The amount of space an object takes up. Okay. Cheyenne says the volume. That's correct. Remember, we did that. You saw that experiment where we put that air has volume, because if it didn't have volume, that piece of paper would be wet. Right. And let's see what we got here. Almost done. What's the unit of to measure length? Measure length. Anybody? Run out of time. Is it liters, meters, seconds, or grams? Yes, Aubriana, thanks. And thanks, Melanie and Revi. Thank you very much. So it's meters. When we're using science, we use the meters here. And then calculate the volume. Remember, it's length times width times height, so it's 5 times 12 times 7. Anybody got that one? Oh, Cheyenne already has it. Yep, 420 centimeters cubed. So 5 times 12 is 60. 60 times 7 is 420. All right, now this one, we're getting close here, almost done here. So What's the volume of a cube with 2 centimeters on the side? So this is going to be, remember, it's 2 centimeters on the side, so it's 2 centimeters times 2 centimeters, which is 4, times 2 centimeters, which is what? Sorry about that. Talking too much? Yeah. Thanks, Alyssa. Okay, where are you? And that's 8 centimeters cubed. Now, you got to make sure that you don't have the squared one. It's not the squared one. It's the cubed one because it's a three-dimensional object. What is the unit for mass? Okay, unit for mass. A is a kilogram, exactly. Kilogram. Right? Mass of an object. Which of these is correct? Changes depending on where it's located, changes depending on the temperatures, changes randomly, or does not change. Yes, thanks, Abriana. It does not change. Mass stays the same, doesn't matter. Your mass stays the same whether you're on the moon or weightless in space. Okay. And suppose an astronaut were to visit a planet, the gravity is half of theirs. Is this mass of the planet would be half of this Earth, twice of the Earth mass, the same as the Earth mass, or 0? I see Revi's doing it, Cheyenne's doing it. What do you think? So half, twice, the same, or 0? 2 questions left and we ran out of time. So the same as the Earth's mass, and the attractive force between two objects depends on the mass is called its weight. All right. Thanks, guys. I know you had to get out of there, so I apologize. We ran over.